and models. Some examples of scale drawings and models are maps. Maps are a scaled down version of the world, and in the bottom corner of every map you will see some sort of legend or key that tells you what the scale of the map is, so that you can determine how far apart from one another the actual cities and countries are on the map. Blueprints are another example of a scale drawing. These are used for architects who are building new buildings or other things like airplanes or cars. Pictures are scaled versions of real-life objects. And of course, model airplanes and trains and other things. And finally, microscope view of something very small is a scaled up version of how that item or object looks. So a scale drawing or a model is just a proportional representation of a real-life object. It can be bigger or it can be smaller depending on the original object. The scale is the ratio of how big the drawing or the model is to the actual object. So for example, if a boat is 2 inches, 15-foot boat is 2 inches long on the model, the scale is for every 1 inch on the model, that is representing 7.5 feet in real life. Okay, so we notice with a scale, obviously this is different from a conversion because there's obviously not 1 inch in 7.5 feet. So what we're not doing here is we're not converting inches to feet or feet to inches in the way that we have done in the past. We are simply looking at a scaled up or down version of the item. And so the units here, we don't have to worry about making these units match. We just have to make sure that all of the units in the model are the same and all the units in the real world example are the same as each other, but we don't need to make the model and the real world units match one another. Let's take a look at an example. An airplane has a wingspan of 24 feet. A toy model of the same airplane has a wingspan of 6 inches. What is the scale of the model? Since we put the model to real life, model comes first, that's 6 inches of the model represents 24 feet of the real airplane. And then we like to simplify it so that it's 1 inch to blank feet. This helps us to really interpret the drawings or the models a little bit more easily. So if 6 inches represents 24 feet, then every 1 inch represents 4 feet. So that's our scale. If an architect's drawing for a new school building shows that the library is 15 inches long, if the scale on the drawing is 2 inches equals 5 feet, what is the length of the actual or real life library? So there's a couple ways we can solve this. If 2 inches equals 5 feet, if we can figure out how much 1 inch would represent, then we can pretty simply calculate the actual length of the library. So if 2 inches is 5 feet, so 1 inch has to be 2.5 feet because that's half as much. So that has to be half as much. So if we have 15 inches for the library, then we would multiply 2.5 times 15 to get the actual length of the library as 37.5 feet. That's one way we could do that. We can also always set up a proportion by taking the scale that we were given, 2 inches to 5 feet, and using that as our first ratio. And then using the second measurement that we're trying to calculate, 15 inches, and that would go on top with the model measurement, so that would be model on top or the blueprint, and the actual library on the bottom, since that's what our original scale tells us. And then if we solve that, you can solve it using cross multiplication. 5 times 15, that's 75. And then 75 divided by 2 tells us that x has to be 37.5 feet. So just two different ways you could solve that problem. Our final example says Heidi is designing a garden that is 16 feet long and 12 feet wide. Find the dimensions of the scale drawing of the garden. Use the scale of 1/4 of an inch equals 5 feet. So again, if we know that every 1/4 of an inch is 5 feet, we should be able to figure out that every 1 inch is 4 times that much. So 1/4 of an inch is 4 times smaller than 1 inch. There's 4 quarters in a whole inch. So that means if we would multiply 1/4 times 4 to get 1 inch, we should also multiply 5 times 4 to get 20. So every inch is 20 feet on the garden. Now, when we're trying to figure out our scale measurements, we know that 16 feet by 12 feet are the measurements of the real garden that she wants to draw. And if every 1 whole inch is 20 feet, you can see that neither of these are even 20 feet, so both of these are going to be less than a whole inch on her drawing. To figure out what they would be, since we're going backwards from feet to inches, instead of multiplying by 20, we're going to divide each one of these by 20. So what that's going to tell us is that 16 divided by 20, that's 0.8 of an inch. This one is going to be 0.8 inches, and this one is going to be 0.6 inches. Another way you could solve this is by using the proportion again. You can use just the original given information. 1/4 of an inch is 5 feet. We were given 2 different measurements. So what's tricky about this is that oftentimes I see students want to put the 16 and the 12 both in this proportion, but then that leaves no space for the missing value. So 16 feet, we have our feet on the bottom, and so the 12 is also feet, so we can't put that on the top. We have to put an X and then solve it, and then we need to do another proportion for the second measurement, which is 12 feet is our width. So for both of those measurements, you need your own or their own measurement or their own proportion. And then if you solve each one of those, of course, you get the same answer. 0.8 inches and 0.6 inches.